Hello everyone, my name is Rafael, and today I'm going to be talking about some of the incredible research that's being carried by the EEE department here at UCL. Specifically, I'm going to be talking about imaging and spectroscopy with terahertz electromagnetic fields. I would like to start by giving us a simple definition of what electromagnetic radiation is. Electromagnetic radiation is a form of energy that surrounds us constantly and is the very foundation of our modern world. Electromagnetic waves are produced by vibrating charged particles and have an electrical and magnetic properties. As we can see here, the wave has a magnetic field and an electrical field. Furthermore, the electromagnetic spectrum is the range of all types of electromagnetic radiations that we can observe. The image that we can see here is the electromagnetic spectrum. On the right, we have gamma rays and the visible light. Visible light is all the light that we can observe with our own naked eyes. On the left, we have radio waves and microwaves, which are used for telecommunications. We're specifically interested in this middle part, which is where terahertz waves are located. What are terahertz waves, and what is terahertz spectroscopy and imaging anyway? Well, as we mentioned before, terahertz waves are in the middle of the spectrum. Terahertz waves are difficult to measure and analyze because they are too small and move incredibly fast. That statement sounds a little bit vague, even I have to admit that. What I mean to say is that their photon energy is too low. And as a direct result of that, they fail to excite electrons in a regular photodetector. This is why specialized devices are needed. Terahertz spectroscopy and imaging is something that has recently gained traction. It is a pioneering technique that uses ultra-fast laser sampling to measure the unique molecular fingerprints of materials and see energy movement on microscopic structures in a way that is safe and impossible for conventional light to do. You may ask, why is UCL doing this? Well, this is some very important research, and the purpose of the research is to advance the understanding and applications of terahertz electromagnetic fields. This again is only possible here thanks to the expertise of Professor Oleg Mitrofanoff, who's been researching this type of wave for decades. Also, the EEE department is home to the ultrafast laboratory. They use a femtosecond laser that produces pulses shorter than a picosecond that allows for the sampling of terahertz waves. Who will benefit from this research the most? Telecommunications companies will be able to take advantage of this research to be able to implement it into their future technologies to be able to create higher transmission rates. Also, the research may be used to be able to diagnose cancer in patients. That is all from me. Thank you so much for your time, and I hope that you now have a better understanding of this topic. Please do feel free to reach to the EEE department for more information.